Hi all, welcome to a real quick video on what are garbage values and how are they going to affect our arrays. And we'll also discuss or talk about how we can use files to write or to read into multiple arrays in parallel. So let's begin the class. So the first one, let's say we've already discussed this one in class. What if I'm creating a variable integer type, and I'm calling this variable as a. And what if I'm trying to print its value? So remember, I just declared it, but I'm not giving it any value. Now, is this legal in C++? Can I simply declare a variable and do a cout? Yes, I can do that. As long as a variable is declared and I'm referring it in my program, that's totally fine. It doesn't depend upon whether I'm assigning a value to it or not. Now, if it doesn't depend upon whether I'm assigning a value to it or not, then what will this particular line cout the value of a is going to be? Well, it's going to be a garbage value. And in this case, when I ran this particular piece of code on my computer, it showed me 4201291. Well, I haven't initialized this, but somehow my computer program picked up this value. This value may change when you try to run this code on your computer, depending upon how the memory is allocated and all the stuff. But this value is subjected to change. But overall, we call this value as a garbage value. So the takeaway is that if you simply declare a variable of integer type, and if you don't assign it, and if you don't give it any value, and if you're trying to print it, it's going to throw us some garbage value at us. So that's what a garbage value is. It's some random value, and we haven't set it in our program. Now, the question is, how does this impact my arrays? So let's say if I'm creating an array of integer type, so this array has 10 elements, and I'm not initializing the array, I'm simply declaring the array. And now, if I try to print all the array elements, if we see, I have 10 elements or 10 components in this array, and all the 10 are randomly initialized, and all of these are garbage values. So that means if I declare an array, and if I don't initialize it, and particularly this array is of type integer components, then all the values in the array are initially randomly set, or there are some garbage values. Randomly set might not be the correct word, or we'll simply call it as garbage values. So be it a variable or be it an array, if they are of integer type, then they're initialized with garbage values. Now, is this the same behavior with all data types? Now, I have several data types. I have variables of several data types created, like an I variable of integer type, F variable of float, D of double, C of char, B of bool, and S of string. So now if I try to print the values, like the code is on the left-hand side, if I try to print the values for each data type, what is it going to be? So for integer, it's a garbage value. For float, it's a garbage value. For double, it's a garbage value. The interesting thing is that for character and for string, it's empty or null value. So, and for bool type, it's a garbage value. So for all the types except character and string, integer, float, double, and bool, for these four data types, it's a garbage value. So the conclusion from the previous code snippet is that integer, float, double, and boolean type of variables, if we are declaring a variable and not assigning a value to it, then they are bound to produce garbage values. That's how C++ is. Now, coming to the data types where we don't see garbage values, but we see empty values is character and string. So both character and string, they produced null or empty values, but they didn't give any garbage values. So just to conclude on this, the first four data types, int, float, double, and bool, they show us garbage values, while character and string, they show us empty values. And now, what does this mean when I'm trying to create an array of these variables? So if I'm trying to create an array of integer, float, double, and character type, that means all the array value components of all these four types are going to contain garbage values. And if I try to create an array of character or strings, then it's going to be empty values. So however it happens for a variable, same behavior is exhibited when we are trying to create array of that particular data type. So character and string will produce empty components, whereas int, float, double, and int, float, double, and bool, this should be bool, my bad. Yeah, so whereas int, float, double, and bool, they contain garbage values, even if we create an array of these data types. But char and string, they contain empty values or null values in short. Now, how does this impact my code? So let's say I'm declaring an array of 10 elements. I'm just declaring, but I'm not initializing. But now for some reason, I just chose to initialize my first 5 elements. So the first element, second element, third, fourth, and fifth. The first 5 elements are initialized with 1, 2, 3, 4, and 5. Now, if I try to find the sum of all the array elements, then the sum value that I got here is not that I'm expecting. Ideally, I was expecting that the ones that I initialized needs to be summed up, and the ones that I didn't initialize, like nums of 5, nums of 6, and so on, the ones that I didn't initialize explicitly, I was expecting that they may contain zeros. But given that this is C++, they contain some like nums of 6, 7, 8, and 9, they contain some garbage values. So the ones that I initialized and the ones that I didn't initialize with garbage values produced an undesirable result for the sum. How do I overcome this? To overcome this, whenever I'm declaring an array, I'll initialize it with zeros. It's ideal if I do this for int, float, boolean, and double data types, because I don't want them to contain garbage values, but rather I want them to contain a value of zeros. Now, the same logic here is the for loop where I'm updating all the elements with zeros whenever I'm creating the array. And now I'm initializing the first 5 elements and I'm trying to sum up all the values in the array. Now the sum value is as expected. It is inclusive of all the first 5 terms, and the last 5 times 5 components in the array, they are explicitly set to 0, so they're not affecting my sum result. So this is how, if we do not initialize, if we just declare an array of integer, float, double, and bool, then this is how they are going to produce misleading results for us. So now, in our lab assignments, sometimes we may have only, let's say, 5 rows of data. Let's say student 1 has 10, student 2 has 20, student 3 has 30, and student 4 has 40, and student 5 has 50. Maybe they could be their subjective scores or something. So I just have 5 lines of code or 5 lines of data available in a file. Now, in some of our lab instructions, we are explicitly being asked that we have to create an array. So in some of our lab assignments, we are being explicitly asked, or in our homework assignments or lab assignments, we are being explicitly asked to create an array with particular size. For example, in our lab 6B, I think we are asked to create an array of integer type. Let's say I'm calling them scores. It could be a different value on the assignment, just cross check it. But on lab 6B, we were asked to create an integer array with 100 elements. Now, I have to read and populate that array from the file. But in my file, I just have 5 data points. So that means scores of 0, scores of 1, scores of 2, scores of 3, and scores of 4 are populated with the data that's available in the file. So scores of 0 will be 10, scores of 1 would be 20, scores of 2 would be 30, and so on. And rest of all, scores of 5 until scores of 99, because array indexing starts at 0 and ends at number of elements minus 1. All these values are bound to contain garbage values, all these components are bound to contain garbage values. So these values will affect our sum, will affect our average value, and so on. So that's the reason whenever you are being asked to create an integer array or float array, double array, or boolean array of a particular size, in this case, let's say 100, but if we don't have sufficient data points, just be careful that since we are creating array of some data types which may contain garbage values, that may gonna produce undesirable effect on our result. So that's why just take care whenever you're dealing with these data types. And now, coming back to the content. Yeah, just ignore this slide. Enough. Coming to parallel arrays. So the concept of parallel arrays is that uh, let's say we have seen already in our lab course videos that Alex has mentioned about two arrays in parallel or simultaneously. The first one being an array of string data type to store names of student. So let's say I initialized several student names in this manner. So this is an array, and let's say I'm calling it as name1, name2, name3, like this. So I initialized the names array with 3 names. So this is how my names array is going to look like. Names, the first component is going to be name1, the second component is going to be name2, and the third component is going to be name3, index 0, index 1, index 2. And simultaneously, I have another array. I have another array called colors, which could be representing the favorite color of each person. So color 1, color 2, and then color 3. So this is our colors array. We have color 1, color 2, and color 3. Index 0, index 1, index 2. So now if we see, I have names and I have colors in two different arrays or two different variables, but both of them are related. There is certain relation. The relationship is that for this person, this is a favorite color. For this person, this is the favorite color. And for this person, this is the favorite color. So now both the arrays, they are of same size, as in they contain 3 components each. 3 components each, and they have some similar they have some connection, like array 1 names has names of students, and array 2 it has the favorite colors of the names available in names array. So if two arrays of same size, or if 2 or more arrays of same size, and if they are related or connected, then we call them as parallel arrays. So this is the logic. If I have to call an array as parallel, if I have to call a bunch of arrays, like here I have array 1 and array 2. If I have to call them as parallel arrays, they should have same size and they should have some relation. And the relationship here is that, the names are stored in one array and the favorite colors of the corresponding names are stored in the second array. So this is what we mean by a parallel array. And now coming to the task. Let's say I have a file in this manner. I have a text file called input.txt and it has 2 columns. How do I know it has 2 columns? I'm separating them with a space, and that's how I'm representing them as having 2 separate columns. So this is my file. So there is a space between whatever the first term that's there, student 1, space, and the second value. Second term, space, and then the value. Third term, space, and then the value. Like that, I have 5 lines of data in this file. So I'm calling the first 5 values, like student 1, 2, 3, 4, and 5 as column 1, and the second column A, B, C, A as column 2. Now, the first column may represent names and the second column represent the corresponding student grades. Now, I'm taking a couple of arrays. The first array is of string type with 10 elements, and the second array is of character type with 10 elements called grades. Now, remember, until and unless I create or, remember, both character and string type, they do not contain any garbage values, but rather they contain empty or null values. So I don't need to worry about populating or flushing off the garbage values. So all I am concerned is that I want to store student names in one array and their corresponding grades in another array. So I'm creating string type of array for storing the student names, and I'm creating character type of array for storing the student grades. But the thing is, if I have 5 lines of data in my file, but still I'm creating 10 components worth of arrays for both names and grades. Now, the way we read a file, remember we have fstream. Either I can do, either I can create a variable of ifstream file, and just a small typo here again. I should be doing something like this. I should create a file and then point it to input.txt, or I can separate them and use the open function available and then point it to input.txt. Up next, I have a while loop. I'm starting at index 0. This index is to keep a track of my array, and I have a while loop. My while loop is that I'll start at the beginning of the file and go all the way till the end of the file. Once it's an end of file, I'm coming out of my while loop. Else, if it's not end of file, I'm reading the first value. I'm reading the first value, student #1 into names index. And then remember our white space logic. Whenever file encounters a white space, it treats whatever the redirection symbol is there, it treats as a second data type, or second value. So I'm pushing that second value into grades. So for every line, I'm pushing the first value till it encounters a white space. A white space is nothing but a space, new line character, or a tab character. So till the file encounters a new line, or tab, or space, I'm reading everything into the names of index. Initially, the index is 0. And once white space is encountered, it treats the second value, which is grade A, as a separate entity, and I'm redirecting it into grades of index. Again, index is 0. So I'm reading student 1 and grades from the first line. This is where my I file is pointing. And remember, these are of string and character data type. Initially, all the uninitialized array values will be empty. Now, it's not end of file. I incremented the index. So I'm moving on to the second line. I'm getting the second student name, second student grade. I'm doing it for the third. I'm incrementing the index. I'm doing it for the third student. Fourth, I'm incrementing the index. I'm doing it for the fourth student. Increment the index, do it for the fifth student. And eventually I reach the end of file. This condition, while not file EOF, this will be false, and I'll come out of my while loop. That means we are terminating the while loop, terminating as in ending the while loop. So we read the data of the first 5 lines into the first 5 components or elements of an array for names and grades in this manner. So both of them are parallel arrays because I know that I'm saving names and grades into each of them. Names and grades are connected. So the first position in names gives the name of a student, and the first position in grades gives the corresponding grade of that particular student. So since these are connected, I'm using a single index to iterate over them, and I'm using file in this manner logically to read the data, to increment the index, read the second components, and so on. This is how parallel arrays are taken advantage of, and we kind of read with a single while loop or for loop, we kind of read data from a file and then populate the array. And again, do not remember, since these are of string and character type, all the elements are initially initialized with null values. And I just used a for loop to iterate over these, starting from 0, going all the way till 10. I'm printing the name of the student, which is available in column 1. So in my code, though I have said the names and grades are the variable names for storing student names and grades, but when I ran the code, I kind of stored them as column 1 and column 0. So ignore these. Student name is stored inside an array of column 1, and student grade is stored in an array of column 2. And if I printed them from starting from 0 all the way up to 9, but not 10, this is how the output is going to be. Since 6, 7, 8, 9, and 10 students, or the index 5, 6, 7, 8, and 9 are not touched or not explicitly set in my code, they are kind of empty or null values. This is how I can use files to read into parallel arrays. And this is how garbage values are going to affect our code if we do not handle, or if we do not anticipate handling garbage values in our code. And now coming to lab 6B, just be careful. Just be careful that if we see the first data file is hardly worth of 8 lines. So first data file contains data of 8 lines. But if we see we have to initialize an array of names and numbers, and we have to treat them as parallel arrays, and we have to give them a size of 100. So that means apart from the first 8 elements, all the other 92 elements for the scores will be filled with garbage values. So if you are doing sum, min, max, count, just be careful that garbage values are there to mess up with your logic. So ensure that you fill them with zeros or you handle them in some way so that your code is not impacted by the garbage values of int, float, double, and boolean data type. So that's all I have within this video. Thank you very much.